Hello, welcome back to LIVENODING. In this episode, I want to share how I set up this rolling balls setup. This is actually quite simple. This is an easy one. Basically, the balls is rolling with a different speed, and they're also traveling with a different length of path. Okay, so this is possible simply by using a couple of nodes, and this is the whole setup. Let me show you in a bit. Let me turn on, maybe I'll turn on like the wireframe, so you can see the balls are rolling and they're all correct. They're rolling correctly based on this provided radius. So if I give like a larger radius, it's gonna travel the same length that I specify here. And also there's a total frame that I set up. All of them have a total frame of 80 with different radius and different travel length. Alright, so that's basically the idea. The equation is basically something like this. This is something that I learned from Uhr Maya channel. So Maya channel, okay, this is Uhr channel. So basically this is the ball with a certain radius. So the ball will travel from here to there. That's the length of the path. So this is the equations and the formula. So the rotations in degrees, and this is the length of the path. This is the variables, and the diameter of the sphere. If the radius of the sphere is like 2, the diameters will be 2 times 2. So something like that. And then the R is going to be the rotations. This is basically the formula. And so I translate the formula into geometry nodes. So for each of these balls, we have a certain radius. Okay, for example, this is the big one. I have a radius of 20, and this is the equations. So I translate it this way. So the way I do it, things inside the bracket, for example, this is the diameters multiplied by pi. This is pi. I just type in pi like that, I get this value. So that's the thing inside the bracket. And then I have this, okay, we have this divide 360 times L. L is the length of the path. So let me show you. As I think for simplicity, I actually use just the original geometry, which is just a simple cube. And then I scale it and translate it and subdivide it so it looks like a ball. Okay, this is with less resolution, so it's gonna be a lot faster. But you can see the animation is correct. So that's the ball part. There's this bounding box to place it on the floor. Alright, so that's makes sense. But there's this thing, okay, there's this thing going on. Okay, basically the time is set to 80 in this case. Okay, so that's how long they're gonna travel. If it goes below after 80, it's gonna just stop. It's not gonna be traveling, it's not gonna be rolling. So for this case, keep it 80. So they're rolling. What we are calculating is the rolling in this case, and we are mapping it. We are mapping the rolling, the number, how many times it's rolling on the floor on the straight path, and we calculate it using this formula. And so in this case, it's dependent on the time, which I set to frame, and based on that value, so I'm using the map range. So this is where you need to rethink the formula inside the nodes. Okay, so this might be slightly confusing, but it's not that difficult. So we got this thing in the bracket, right? Diameters times pi. Diameters is 2 times radius. So we get that already from our sphere. So we divide it 360 times length. The length of the path in my case is based on this curved line. So ideally the ball can actually roll in a different path, maybe not like a straight path, maybe like any kind of curve, right? And then the ball needs to travel along the path. So that could be for future live noding. In this case, it's just like a simple curved line in the directions of the y. So the curves have length, and then I multiply this with 360, all right, and I divide it, and we get the value. This value is actually, I believe this is how many times the ball is rolling, and I convert it into radians and multiplied it with minus, so it's rolling the correct rotations, and I simply use it to transform the sphere. But this is to transform the sphere rotations, right? So that's been taken care of thanks to the formula, thanks to Uhr. While the translations itself, so the ball needs to be on the ground, so it's translated up, and then the ball is also traveling in the y directions. It's traveling, how long is the traveling distance? It's actually the length of its traveling. If I specify 100, so the big ball will need to travel 100 meters while it's rotating. And yeah, it's rotating how many times? Okay, let's say the ball have radius of 25, so it needs to travel 100 meters. So how many times it's rolling? 2 times. That's my guess, but I need to test that. But yeah, so that's basically the idea. If I change the radius, you see the ball is always stay on the ground, so that's good. So that's basically pretty much the setup. It seems complicated, but this is actually one of the simple one. I think Blender, of course, is really good for a lot of things. I think for math, if you're math teachers and you're teaching all this formula and you want to teach this to your students, and visualizing it inside Blender can really help. Of course, there are many ways you can use different code. In fact, this formula is a single lines expressions. You can just use expressions and then just use like a drivers, and you can have like a balls that's rolling. There are many examples that's dealing with rolling. This is actually good. This is better for things like bicycles or wheels, right? If the wheels, how many rotations, how many times it rotates for wheels to go from distance from 0 to 100 or something. That's basically the setup, you know. There's nothing, it sounds complicated, but it's not. This is one of the basic one. And once you have understand the expression or the formula and what's the required variables, this is one example that will work. What's might be slightly complicated is because we are mapping the range, but this is also kind of an interesting concept. So minimum, maximum, so this is the time that's controlling and remapping the value of what we specify here. So there's the radius, there's the total frame, and the length is traveling. Okay, so that's really important. Value of variables that we plug in, and geometry nodes will just do it for us. Currently is actually doing this into the geometry itself. Ideally, you want to actually turn this mesh into an instance. So you need to instantiate. Once you instantiate the geometry and then you perform like rotations to the instance, it's gonna be better. Let's say if you want to make like, I want to make like 100 balls with random radius, all traveling in a random with random total frame and the length, then you need to use instancing. Okay, it's like working with particles, but for now it's just I simply duplicate the balls. I can make like a new duplicates like that, change the radius, change the travel length. So we have these balls that's traveling and rotating correctly without us even need to animate it. Okay, so while with the shader, okay, the shader itself, it's pretty simple. I'm using wave texture. This is pretty cool with a bit of distortion, so it's looking like a marbles. I can get rid of the distortion, so it's just like a simple wave. And so the wave texture is cool. I plug this into the roughness, so it behaves with the metallic. I'm using this color ramp. This control the wave color. On top of that, I have a random hue for each of the balls mixed together for our balls. Right, so that's basically the setup. Okay, so it's a pretty simple, but it's a fun example, and give this a try. Actually, you can follow the node setup. You can try to recreate it. I suggest you to, if you feel challenged, just look at the formula and try to rebuild the setup yourself. If you fail, then you can look at my setup. It's and you can make this even more complex. Like, okay, I show you something. Okay, if you tap D, hold D, and then start drawing with the left mouse button, you can draw. Okay, this is quite common. It's actually a good idea. So the ball is rolling and it's traveling this length of distance. So this is the formula. So the ball has radius and it has the diameters, 2 times radius, and then how many times it's rolling to reach the length. Okay, so that's what we are calculating here. Yes, of course, this is I'm holding D and right mouse button to erase. There's a whole explanations on the formula that you can find on YouTube, or actually you watch this video by anyway, he tried to explain the whole thing. I will provide you the link so you can study the math, and then also study a little bit of Maya, and also you study a lot of Blender and geometry nodes. The same concept is the knowledge that you need to understand, so you can use it on any 3D package or game engine. Alright, so thanks again for tuning in, and I'll see you next time. Thank you. Bye.